Hi guys, it's Mrs. Mancuso here to do a little review. It's time for the 30-week test. So give me your chemistry questions. Let me know what you would like to go over. I will post this on YouTube. So if you go on YouTube and you go to Nancy Mancuso, you will see me and I will post it on there. I also have so many videos on there. They're in a playlist. So if you go into the playlist and you go to review, or I think it might be called Regents review, then you'll see all the different topics from the year. So if you need just specific information about something, let me know. Put your questions right here in the comment section, and I will go over whatever you would like. All right, so reviewing for the 30-week chemistry test. Let me know what you would like help with. I'm going to start off with acids and bases because they are the most recent thing that we've done. And know that when I'm doing this review, I'm going to do Regents chemistry review, but I'm also going to do a little bit of honors because I have an accelerated class. So there's some things that are on their test that are not on the Regents test, but I want them to be prepared as well. So when you're talking about an acid, acids always have the same definition. They are a proton donor. So hydrogen is element 1, so it has 1 proton. It's a positive, so it's lost its 1 electron, and its mass is 1, so it doesn't have any neutrons. So when you say hydrogen ion, it's the same thing as saying a proton donor, because a H plus only has 1 proton. So these are some typical acids: HCl, H2SO4, H3PO4, HNO2. Oops, I just wrote that wrong. HNO2. And let's go over naming first, because a lot of people were asking me about how to name acids. So first of all, this is a binary acid. It's binary because it only has 2 elements. And whenever you have a binary, you have to start with the prefix hydro. So this would be hydro, and then Cl is chlorine, so chlor, and then you end it with ic, acid. These are all ternary, which means they have 3 or more elements and they use a polyatomic ion. So I need to go to my reference table and I need to go to table E. Here it is, polyatomic ions. And what I do is I look up SO4. So over here, SO4 is sulfate. Whenever it ends in 8, you change it to ic. So this would be sulfuric acid. All right, let's try the next one, PO4. You find it, it's phosphate, so that means it would be phosphoric acid. And then this one, NO2. So I go find it, and it's nitrite. Now, if it ends in ITE, you don't put ic acid, you put us, so nitrous acid. Now, another trick is you just go to table K. This is what I always suggest for my students to go first. If you want to know the name of an acid, first check and see if it's on this list. This list also reminds you that when you have binary, you have to put hydro. If you look up NO2, it ends in ite, so they changed it to us. And if you look up NO3, it was 8, so they changed it to ic. So this is a great way either to find what you're looking for or to figure out how to name any acid. The bases are down here, so let's talk about bases for a little bit. Bases actually have 2 different definitions. A base is either an OH minus donor or it's an H plus acceptor. So if you think about the pH scale, here's my pH scale, and I've got 7 in the middle here. Oh, this could be a 0. All right, so my acids are down here and my bases are here. This is the greatest concentration of H+. This is the greatest concentration of hydroxide. Oh, and also know that when you put H+ with water, it's hydronium. H3O plus and H plus, as long as you're talking about something aqueous, you're talking about the same thing. So if you have an acid, it donates H plus, so it helps bring it more this direction. And let's look at these 2 choices. If you have a base that is a metal with an OH, it's an Arrhenius base, and it's definitely going to increase the OHs, so it's going to bring it this direction. If instead you have something like NH3, NH3 is ammonia. It will pick up an extra H+, and so by taking it away, it's moving it more in this direction. So that's why it acts as a base. This does not have an OH- to donate, so instead it picks up an H and becomes NH4+. All right, let's move on to some more stuff with acids and bases. Let's talk about neutralizing. If you neutralize something, you are taking an acid plus a base. You always make an ionic compound or a salt, and you always make water. So when you are writing out the products, let's say we have H2SO4 and we have magnesium hydroxide. All right, what you have to do is the same thing as always. My H is going to end up with my OH. My Mg is going to end up with my SO4. Put the charges on everybody. So +1, -2 on the SO4. You can look that up on table E. Mg is a +2, OH is a -1. When you crisscross, you get MgSO4 because the +2 and the -2 cancel out, and you get H2O. And to balance it, I have 1, 2, 3, 4 H's, so I'd have to have 2 waters. Now, if I was doing a neutralization problem, a calculation, I would use the formula MAVA equals MBVB. The molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. So let's say the molarity of my acid was 16.4 molar. And let's say I had 25 milliliters of it, and I don't know the molarity of the base. The MgO2, I do not know what it was, MgOH2, but I know that I used 64 milliliters, okay, 64.0. I have 3 sig figs in each of these, so I know I'm going to want 3 sig figs in my answer. And now I want to check and see if they're equal givers. And what I mean by that is this H2SO4 can donate 2 H's. This MgOH2 can donate 2 OHs. So if you want to, you can multiply both sides by 2, but you're doing the same thing, so you really don't have to. These two are equal givers, so they cancel each other out. So now I take my calculator, and I go 16.4 times 25 is equal to 410 divided by 64. I get 6.406, and I want it rounded to 3 sig figs, so the molarity of my base is 6.41 molar solution. Let's do another one, and we'll do some practice when they are not equal givers. So let's try H3PO4 and CaOH2. So again, my H and my OH are going to come together. My Ca and my PO4 are going to come together. This is a +1. This is a -3. You can tell because the 3 crisscrossed up, or you could look it up in table E. Calcium is a +2. Hydroxide's a -1. When you crisscross, you get Ca3, PO4, 2 of them, and you get water. To balance it out, 3 calciums, so I need to put a 3 here. 1 PO4, 2 PO4, so I got to put a 2 here. Count up your H's. 2 and 3 is 6. 3 and 2 is 6. So I have 12 H's, so this has to be a 6 here to balance it out. Come up with another problem. So let's say I have 18.0 molar H3PO4. And I needed 128 milliliters of it, equals, and let's say the base, I do not know the molarity of the base, but I know that I used 61.5 milliliters. My check and see if they have equal givers. This gives away 3 H's. This gives away 2 OH2s. So on my acid side, I need to multiply by 3. And on my base side, I need to multiply by 2 to show the ions they can donate. Now I go ahead and do my math. 3 times 18 times 128 is equal to, and then divided by 61.5 divided by 2. And I get, and again, I want 3 sig figs because I have 3 sig figs in each of these values. The number of ions is obviously not a sig fig. So the molarity of my base needs to be 56.2 molar. All right, so that is how you solve that one. All right, let's think about anything else from the acid-base unit that is for the reagents. So here, table M is really important. Table M tells you your indicators. So for example, methyl orange is an indicator. If you use methyl orange and it comes out red, that means the pH is 3.1 or lower. If it comes out yellow, it's 4.4 or higher. And if it comes out somewhere in the middle, it will be orange. So if my pH was 3.5, the color would be orange. So sometimes they give you the results in 2 things. So let's say that litmus is purple and bromothymol blue is yellow. All right, so now I want to figure out what range this pH could be. So if litmus comes out purple, I know it's between 4.5 and 8.3. And if bromothymol blue comes out yellow, I know it has to be 6 or less. So now my range is 4.5 to 6.0, and that's my narrowed down range. All right, I want to go over a couple things that are important for accelerated. Oh, actually, I just thought of one more thing, the pH scale. Let's talk about moving different levels. So let's say I have a pH of 8 and it goes all the way down to a pH of 5. What you do, first of all, your H plus concentration is increasing because you're becoming more acidic. So you put your 1, and then 8 down to 5 is 7, 6, 5, 3 zeros. So it is becoming 1,000 times more concentrated with H pluses. So every step on the pH scale is a factor of 10 times greater if you are going to the H plus side, or if you're going this way, it's 10 times more OH minuses. It depends on if you're going the acid direction or the base direction. All right, so in accelerated bio, we look a little bit more at pH and the concentration of H plus and OH minus. So let's say my pH is 3. The first thing you should understand is that if my pH is 3, then my hydrogen ion concentration is going to be 1.0 times 10 to the negative 3. All right. If instead you gave me the concentration of H plus, so let's say the concentration of H plus is 6.02 times 10 to the negative 5th, and I want to find the pH. Well, pH is equal to the negative log of your hydrogen ion concentration. So what I have to do is I got to grab my calculator again, and I got to punch in negative log. And then I punch in 6.02 times 10 to the negative 5th equals. And I find out that my pH is equal to 4.22. All right, we can also find the pOH from this. So if my pH is 4.22, then that tells me that 14 minus 4.22 is equal to 9.78. So my pOH has to be 9.78. If I go up to this problem that I did first, if this was my H plus, then I know my OH minus has to be 1 times 10 to the negative 11, because these two numbers have to add up to negative 14. All right. If you have questions, please feel free to write them in the comment section, and I will specifically go over questions that you have. All right. I'm going to move on and do some kinetics, because kinetics was the unit before acids and bases. So if you think of something else, let me know. But in the kinetics unit, we talked a lot about speeding up the rate of a reaction. So when you have a reaction, I'm just going to go to table I and choose a reaction so we can talk about all the different things about a reaction. So here, I'll just pick this first one on the top. So it's CH4, and it's a gas, plus 2 O2s, and that's a gas, makes CO2, which is a gas, and 2 H2Os, which is a liquid. First of all, the delta H. So the delta H is equal to negative 890.4. So that information tells me that this is an exothermic reaction in the forward direction. So that 890.4 belongs right here. That's how many kilojoules of heat are released when you do the forward reaction. All right, so this forward reaction is exothermic, and if I had to draw a potential energy curve, exothermics start out high. You still have to add a little energy, but then they release a lot of energy. So let's talk about what all of these parts on the graph mean. This is the energy of my reactants. That's what I'm starting with. At the end, I have products. Sorry, that should just be a P. At the end, I have products. So there is my reactants and there is my products. The difference between your reactants and your products is what's called your delta H, your heat of your reaction. That's always equal to P minus R. So if you start off with your P being a really low number and your R being a high number, your value comes out negative like this one. So it proves that you have a negative delta H and you have an exothermic reaction. All right, something else that's really important on this graph is the activation energy. So activation energy is how much energy do you need to get a reaction started. So here's your activation energy. So your reactants had this much energy, but you had to add a little bit more. So even if you have a stick of dynamite, you still have to add a little bit of energy to get it to react, and then it will explode and you will release a lot of energy and you end up with ashes, and those have very little energy. All right, what else? I want to talk about how you can change the rate of a reaction. So let's say we wanted to speed up this reaction. If you want to speed it up, you have a gas and a gas. So one thing you could do is change the pressure. Whenever you talk about pressure, you want to count up the moles of gas. So there's 1 mole of gas here. There's 2 moles of gas. Oh, hey, Joey, miss you too. 1 mole of gas here, 2 moles of gas here. So 3 moles of gas on this side. Over here, I have 1 mole of gas, and this is a liquid, so liquids don't count. If you increase the pressure, you are going to decrease the volume, which means you want to favor the reaction that makes less moles of gas. So this would really favor the forward reaction. It would really get it hot. It would get it burning. It would get this reaction happening. So increasing the pressure. Another thing that you can always do is increase the concentration. So increasing pressure worked, increasing concentration worked. For this reaction, increasing the heat would actually favor your reverse reaction. So increasing the heat on this reaction would favor the reverse. Some other things are adding a catalyst or changing the surface area. We have a gas, so I can't change the surface area of this one. You sort of never go wrong with your increasing concentration one. That sort of works no matter what you have. Surface area is another one, but again, if I have a gas, I can't change the surface area. All right. What else do you want to go over? You guys got to ask me some questions because I'm not sure what you want to review. If you have a reaction at equilibrium, I can go back to this for a second. If you have a reaction at equilibrium, that means the rate of the forward and the rate of the reverse are equal. So let me just write out this reaction again. CH4 plus O2 makes CO2 and H2O. All right, let's just talk about this reaction for a little bit. If you are doing this reaction, and I know that there's 890.4 kilojoules of heat on this side. Let's just say I increase the temperature. Wherever you add, it will move away. So if you add over here, you are going to shift the reaction to the left, or you're going to favor the reverse reaction. When you do that, these molecules will collide more and be used up. So both of these are going to go down in amounts. And everything over here on this side is going to increase in amounts because you are producing more of them. All right, let me do one more example of this kind of problem. Let's say that I decrease the amount of oxygen. So here's my oxygen. If I decrease this, that means I move towards. So now I would again favor the reverse reaction. These amounts will go up. The goal is always to get back to equilibrium. So if I decrease this, I certainly want it to go back up. So I favor the reverse reaction. These will collide and decrease in number, and these will be produced and increase in number. All right, give me a topic, people. Not sure what else you want to review. That's really like the new stuff. I don't know if there's any old things that you would like me to go over. What would you like some help with? The unit before that was solutions. So in the solutions unit, there was stuff like concentration, if you want me to go over like calculating molarity or calculating parts per million, or solubility using table G or using table F. Ooh, someone gave me a question. Okay, can you go over using table I? Absolutely. Here's table I, and so table I gives you the heat of a reaction. So when you use table I, you are looking up a reaction. So let's say I'm looking for this reaction right here. I find it, I go over here, and it gives me negative 566. That tells me that this reaction is exothermic. It produces heat. Now, if I'm not sure and I forget what the signs are, there's a reminder right down here. It says the delta H values are based on the molar quantities, and then a minus sign indicates exothermic. So it would be an exothermic reaction, which again, when you draw an exothermic reaction, you have the big down curve because you're releasing energy. Let's say if this was the reaction, but it's in the reverse direction, that means I use the same number but change the sign. So if you change the direction, you change the sign. So instead of doing the forward reaction, you'd be doing the reverse reaction, and the reverse of this is a big uphill, so that's definitely an endothermic reaction. Another thing that could happen is this might be a reaction, but instead of being 1, 1, and 1, it might be 2, 2, and 2, which means you got to double this number. So those are like all the tricks or all the things that you need to do with table I. If you need to write in the actual value, so let's do this reaction. N2 plus 2 O2s make 2 NO2. All right, I go find it. There's my reaction. I go find it on here. Where was that? 2 N2s and an N2 and 2 O2s make this. That's positive 66.4. If my delta H is positive 66.4, I know it's an endothermic reaction. So the graph is going to look like this. You have to add energy in. It also tells me I have to put the 66.4 kilojoules on this side of the arrow. All right, it has to go in for the reaction to happen. So that's about everything that you use table I for. What else? Give me more, Gracie. Give me more questions. What do you guys want to review? If I start just making a list of different things, vapor pressure is another one that sometimes people forget about. Vapor pressure, I might as well do it because vapor pressure is super fast. That's this table right here, table H. So as you increase pressure, you increase the boiling temperature. So you could go across, like 101.3 has a little dotted line here because that's the normal atmospheric pressure. So if I go across, this is the temperature that propanone would boil. This is the temperature that ethanol would boil, water, and ethanoic acid. So another sort of common question is which one has the strongest intermolecular forces? Whichever one has the highest boiling point is going to have the strongest intermolecular forces. So it would be ethanoic acid. Another common question is as the temperature increases, what happens to the pressure? And it increases. That reminds me of gases. Gas laws were another thing that we did. So talking about like what's ideal for a gas. Gases really love to spread out and take up as much room as possible. They are almost always non-polar molecules, so they really have no attractions to other things. So what's best for them is high temperatures and low pressures because, again, they don't want to be close to each other. They move in constant straight line motion, and if you have a gas calculation to do, you want to do your P1 V1 over T1 equals P2 V2 over T2. You got to make sure that your temperatures are in Kelvin whenever you do these calculations. All right, that's reminding me of heat. Heat's another thing that some of my kids had questions about today. So heat questions, there's 3 styles. Q equals MC delta T, that's whenever you're changing temperature. Q is equal to MHF. HF is the heat of fusion. So if you are melting or freezing something, this is the calculation you're going to want to do. Or Q equals mHV. And HV is the heat of vaporization. So if you are boiling or vaporizing or condensing, this is what you want to do. So change temperature, melting, freezing, boiling, evaporating. So let's think about a problem. Let's say we have 67 grams of ice and it's melting at 0 degrees Celsius. And I want to know how much heat that's going to require. All right, so I want this formula, Q equals MHF. My mass is 67, and the heat of fusion. So if it is water, you grab your reference table, you go to the very front to table B, and the heat of fusion is right here, 334. So you take 67 times 334. You grab your calculator, and you get 22,378. And heat is measured in joules. So there is your answer. That's what you do. Now, I didn't use the 0 at all. It was not necessary, but lots of times they throw that in there. Do not let that influence any part of your calculation because they didn't ask for the temperature here. And even up here in this calculation, they're only asking for the change in temperature. So you would just be marking like, oh, hey, if it's going from 50 degrees to 70 degrees, well, you just subtract. That would be 20 degrees. You just put the 20 in your calculation. All right, people, I need some questions. What would you like me to go over? Give me a topic and I will review it. Hi, Maddie. Give me a question. Hi, Nina. Love seeing all the little faces that join on here. What would you like me to review? Give me a topic, people. So I started writing some of these. If you have questions about any of this stuff, or if you have any old questions or bonding questions or Lewis dot diagram questions, let me know what you want to review. Otherwise, in the very beginning of the video, I mentioned this. You can always go onto my YouTube channel. So go to YouTube, punch in Nancy Mancuso. You will see my little smiling face. Go to the playlist, and there's Regents Review. I think there's definitely more than 30 videos, and they're on every single little topic you can imagine. So just watch them, get a quick review of whatever content you feel like you need some extra help with. All right, I'm going to sign off. Have a great night, everybody. Good luck on your test tomorrow.